Here is the next example. By using Mason's gain formula, find the transfer function of the following signal flow diagram. So step 1, find all the forward paths. Okay, how many forward paths are there? Forward path is nothing but starting from the input, reaching the output without going through any path more than once. Okay, so that's I see only one path, which is P1 equal to Z1, Z2, Z3. Of course, I need to multiply those ones, but 1 multiplied by something equal to something, so I'm ignoring that 1 there. Are there any forward paths? I don't see any forward paths. Now step 2. So step 1, forward paths. Now step 2, find all the loops. Okay, find loops. So how many loops are there? I have 3 loops. Path I'm indicating with P, loops I'm indicating with L. L1 equal to minus G1 H1, L2 equal to minus G2 H2, L3 equal to minus G3 H3. So there are 3 loops. Now, are there any other loops? As mentioned, please review it one more time, so that way if you miss any loops, you can note it down. Okay, if you miss one loop, that's going to give you wrong answer. You will lose lots of points for that. That's our step 2. Step 3, find all non-touching loops. 2 non-touching loops. Okay, so 2 non-touching loops. I can see L1 and L2, they are not touching to each other. L2 and L3, they are not touching to each other. L3 and L1, they are not touching to each other. Okay, so that's non-touching loops. Now here you can write it down, the whole multiplication, or leave it like that. And step 3 itself, also write 3 non-touching loops. 3 non-touching loops. Okay, so here all L1 and L2 and L3, all 3 of them are non-touching, so all 3 of them are non-touching loops. Now we're going to find delta equal to 1 minus L1 plus L2 plus L3. I'm going to write down L1 plus L2 plus L3 plus sum of these multiplications of all 2 non-touching loops. So L1 times L2 plus L2 times L3 plus L3 times L1. Okay, minus sum of the multiplications of 3 non-touching loops, which is L1, L2, L3, plus if you have some other things like Lx plus Lx, Ly, Lz, okay, you're going to add that Lx times Lx, Ly, and Lz. Here I don't have those, so I can ignore this part. Okay, so that's what it is. That's the delta. So I have, if I write it down, delta equal to 1. Everything has minus, so it's going to be plus, minus of minus, which is going to be plus 1 plus Z1 H1 plus Z2 H2 plus Z3 H3 plus Z1 Z2 H1 H2 plus Z2 Z3 H2 H3 plus Z1 Z3 H1 H3. Okay, that's the second part. Minus, now I'm going to multiply L1, L2 and L3. So minus of minus plus, plus times minus minus, minus times minus plus. At the end I'll end up with plus L1, L2, L3, which is Z1, Z2, Z3, H1, H2, H3. That's our final delta. Okay, so this is my delta. Now I'm going to find delta 1. Okay, delta 1 is copy delta and eliminate any element or any path touching path 1. I mean any one of these elements touching path 1, or any node of this is touching path 1. So I'm sure there is only one path, and either element is touching or the node is touching. So in this case I have delta 1 equal to 1. Okay, so the transfer function equal to p1 delta 1, which is p1 delta 1 over delta. So that equal to p1, I have path 1 is z1, z2, z3, delta 1 equal to, let's write, I mean delta 1 equal to 1, and delta is right there, so copy everything, which is 1 plus z1 h1 plus z2 h2 plus z3 h3 plus g1 g2 h1 h2 plus z2 z3 h2 h3 plus z1 z3 h1 h3 plus z1 z2 z3 h1 h2 h3. This is the transfer function of that whole for this given signal flow graph or signal flow diagram. Thank you.